We're going to be solving for tension 1 and tension 2 on this hanging object whose mass is 8 kilograms. Step 1 of solving any forces problem is we have to draw all of the forces on it. We've got them. We've got T2 here, T1 is there, and the force of gravity. Step 2 is positives and negatives. Positive up, positive right, down, and left are negative. So now what we need to do is our third step, which any force that's at an angle, and T1 is at an angle, we need to break into its components. So now we got to draw them first. So the first component we'll draw upward, and we'll call that tension in the y direction. And the next component goes to the left, and we'll call that tension in the x direction. Now we need to figure out what exactly those are. So tension in the x direction on this particular right triangle right here is the opposite side of our 35-degree angle. So that means we're going to be using sine of our 35-degree angle. And we don't have a number for tension 1, but that's okay. We'll just write down T1, and we will use this in a little bit. The next one was tension in the y direction. And that's the adjacent side, so that's going to be cosine of 35 degrees multiplied by T1, because we don't know what T1 is yet. Now that we've got that, we can start adding up our stuff in the up and down and left and right directions. I'm going to start in the up and down. If you go left and right, that's okay, but you're going to get blocked because you don't have any numbers. So up and down we'll do first, and I take all my forces that are going upward, which is just tension in the y direction, minus any forces going downward, and that would be the force of gravity. Since this is in equilibrium, everything adds up to be 0, which means I know that tension in the y direction has to equal the force of gravity. Now I'm going to expand what tension in the y was, which is this cosine of 35 degrees times T1 in my equation. Cosine of 35 degrees times T1. Now why am I doing this? Because I don't want tension in the y, I want actual tension. And I know that the force of gravity is the mass, which is 8 kilograms, times 9.8, which we'll plug in on our next step. Now we're just going to solve for T1, so I'm going to divide the cosine of 35 to the right side. And what I get is that T1 equals my force of gravity, which is 8 kilograms, times 9.8 meters per second squared, divided by my cosine of 35 degrees. And when I plug all of that into my calculator, what I should get is that tension 1 is 95.7 newtons. Now that I have that, I'm going to go to the left and right directions, and I say, okay, anything going to the right? There is, and that is T2. Anything going left? Yes, there is. That's tension in the x. And since that's all the things going left and right, they add up to be 0, which means that T2 has to equal tension in the x. And we can plug in what we know tension in the x is, which is the sine of 35 degrees times T1. And we know what T1 is. We just solved for it, which is 95.7 newtons. So we plugged it into our calculators, and we know that T2 is 54.9 newtons.